In this video, we are going to do these two questions, which is based on alternate segment. So before we do this question, let's understand what is an alternate segment means here. So if I make a circle and any tangent, let's say I make this tangent over here and taking say this P as the point of contact, and then I'm going to make a chord over here such that the chord has one point coinciding with the point of contact. So let's name this chord as AB. This is AB, right? So now I can see that this chord is actually dividing this circle into two segments. One is this, and other is this. Now, if I make an angle subtended by this chord on this major segment, let's say I name this angle subtended by this chord over here as say P, that is angle EPB. And I'm going to take another angle subtended by the same chord on the remaining part of the circle, that is on the minor segment over here. This is the angle subtended by the chord in the minor segment. And I name this angle as say Q, that is AQB. Now what is an alternate segment? This is the angle subtended by a chord with the tangent is equal to angle subtended by the same chord on the alternate segment. That means this. So these two angles will be equal by the alternate segment. Now we can also make another angle. Let's say if I take this time, this is an angle made by again the chord AB, right, with that of the tangent. Then this angle should be equal to the angle made by the same chord on the remaining part of the circle. So you can figure out that this time the angle is made on the major segment, then this angle should be equal to the minor segment. So you can see from here that when this angle is made by the tangent and the chord AB in the minor segment, it was equal to the angle made by the chord in the major segment and vice versa. And that is the reason why it's called alternate segment. So let's see how can we use this alternate segment property to solve these two questions. Let's begin with the first one. Now, in this question, we know the value of this angle, and we can clearly see that this angle is made by this chord AT and the tangent this. And that is made on the major segment. So as I said that this angle will be equal to angle subtended by the same chord, that is AT, on the remaining part of the circle has to be this, that is called alternate segment. So we got this angle. I can say now this value of this angle is going to be 98. Now further what you can see that in this triangle we are given two sides equal. So we can use isosceles triangle property to get the other two angles. So over here I can see that these two angles are equal. So let's say if I take this angle as x, so I can say x plus 98 is equal to 180. That's by angle sum property. 2x will give you 82. That implies x is equal to 41. So now we know the value of these two angles, that is this is 41 and this is 41. Next, we have to get this angle keeping in mind. Now check, we can once again apply the alternate segment property. And how? Let's see. We are talking about this angle over here. In this angle is subtended by what? This is made, not subtended, this made by this chord, that is chord BT, and the tangent, there is only one tangent, this tangent. So this angle should be equal to, one more time, this is the chord and this is the tangent. This angle should be equal to the angle subtended by same chord on the remaining part of the circle. That's by alternate segment. So now we can say using alternate segment that this should be equal to 41, right? So now we know this angle. This angle also is 41. So here now we can apply, to get this angle, we can apply angle sum property, but this time on this triangle. So check in this triangle. We know the value of two angles and we can get the third angle, right? So let's do it over here. So that the angles over here, let's say if I take this angle, that is unknown angle, which is C over here. So angle C plus angle A, which is 41 as for the figure. And the third angle is this, right? So 41 plus 41 is how much? 98. This is 98 is equal to 180. So angle C will come as what? So it's 180 minus 98 and then again subtracting 41. So it should give you 41. So we got this angle as 41 degree. That's how we will do. Now let's come to the next one. And in the next question, you can see we have to determine this angle. We are given these two angles over here, 45 and 68. So as I said, this is based on alternate segments. So let's see. First of all, we'll be joining this chord AB. Now over here, this is the angle made by this chord AT and this tangent PQ. So this angle should be equal to the angle subtended by the same chord on the remaining part of the circle, that's on alternate segment. So this angle should come as how much? 45 degree. Now in the same manner, I can say that this angle is subtended by this chord. This time the chord is TB and the tangent is this. So this angle should be equal, that is 65 I'm talking about, should be equal to the angle subtended by the same chord on the remaining part of the circle, that is alternate segment. So this angle should come as how much? 65. Right. So now what you can see that over here, we know the values of two angles in this triangle. But the triangle here is this, right? We are talking about this triangle, that is ATB. We know the value of two angles, so we can find the value of the third angle. That is, say if I take this angle, one is 65, other is 45. The third, which is angle T, that's missing here. This is angle T is equal to 180. So angle T will be how much? This is 110. So the sum is 110, right? So this is minus 110. So angle T comes out to be 70 degree. So that's how we will do this question.